All right. Today we're going to go over factoring. All right. Oh, okay. All right. Okay, so when we start factoring, the first thing you always want to check for is the greatest common factor, or the GCF. All right, and so as usual, I'm, hoping and assuming that you've probably learned this before, but just maybe a little bit of different way of looking at this and explaining it a little bit more. So if you're factoring out the greatest common factor between these two terms, the greatest common factor would be 2c. And so what that means is you're going to write down the GCF in the front. So basically, so this is like you're multiplying by 2c. And then what you're going to do is you're going to divide each term by 2c as well. So anytime we're factoring, we're not really changing the value of the expression. We're just changing the way that it's written. So if you're multiplying by 2c and then you're also dividing by 2c at the same time, those cancel each other out. So that way you're not really changing the value of it, but you are just changing the way it looks. So that 2c stays in the front, and then that would cancel out. So that all you'd have left there is c. And then also thinking of it this way helps you to remember that you're supposed to have a 1 here, because 2c divided by 2c is 1. All right, so even though we say those cancel out, you still have to have like a 1 there. So your answer there would be 2c times c plus 1. All right. And like I said, there's a lot here, and I'll just kind of skip through, not do all of these problems, but let's just do number 3. So in that case, the GCF would be 2x, because they all have x's, but you have to go with which one has the least amount of x's, which is just this x right here. So that way, when you divide it, you'll be able to reduce everything down. So if you divide each of those by 2x, that would be 4x squared minus 5x minus 7. So 2x times all that. And so whenever you're doing factoring, you can also check by distributing the 2x. Then if you do that, it'll get back to what you started with. So like on number 4, in that case, the GCF is going to be, let's see, 9. And then for the x, you would do x squared. All right, so you'd have that 9. Yeah, so like I said, whichever one has the lowest power of x, that's what your GCF is. So you can divide it out. So 9x squared, and divide that by 9x squared. So that would make that 4x to the 4th plus 5x squared minus 2. Okay. All right. Number 5, the numbers don't have a greatest common factor, but they all have, but they do have for the letters. So the GCF in that case is b squared, and you factor that out. So that would be 2ab plus 3x minus 5b squared plus 2. Okay. For number 6, our GCF is going to be 7 ABC. So, oops. All right, so that's going to leave us with 5C minus 7B. Okay. There's that. All right, and on number 7, it looks a little bit different, but it's still factoring out the GCF. So in this case, think of it as this is one term because it's that's multiplying together, and then this is another term. And so what those two terms have in common is sorry. Okay, what those two terms have in common is the thing that's in parentheses, which is 3a plus b. Okay, so this is where it comes in handy to do, like I said, where you're going to divide, if you divide that by 3a plus b, and you divide that by 3a plus b. So then the 3a plus b cancels out. And of course, though, you still have the 3a plus b in the front. But then all you're left with is 6 minus z in the second set of parentheses. And you could check that answer by foiling it, I guess. So then like for number 8, it's kind of the same thing. Like your GCF is going to be x minus 7. So that's going to be x minus 7 times 5x plus 3. And then on number 9, your GCF would be 3y plus 5z. So your answer would be 3y plus 5z times 7x minus 6t. And then on this last one, your GCF is going to be c plus 4d. So remember, when you divide this by c plus 4d, you're still going to have a 1 there. So you're going to have c plus 4d in the front, and then in your second set of parentheses, you're going to have 1 plus 7c squared. All right. All right, so then we will talk about factoring by grouping. So this is a method that you use when you have, usually use this method when you have 4 terms. Sometimes it could be more, but mostly we're just going to talk about when you have 4 terms. So what you do is you're going to group the first 2 terms together, and you're going to group the last 2 terms together. And then you're going to factor out the GCF from each of those 2 groups. So from the first group, the GCF would be x. And when you factor that x out, it's going to leave you with y minus 1. And the GCF on the second group, and bring that plus sign down. And on the second group, you're going to factor out the 4. And then when you do that, it's also going to leave you with y minus 1. So now we can see that what we have in those parentheses is the same. And so we can, now the y minus 1 becomes our GCF that we factor out. And then in our second set of parentheses, we have x plus 4. So our final answer is y minus 1 times x plus 4. And if you FOIL that, you would get back to this. Okay, number 12, same thing. So let's say we group the first two terms together, and the GCF there is x squared. And when we factor that out, we're left with x minus 6 in parentheses. Bring down the plus. And for the last two terms, the GCF is 2. And when we factor that out, we're left with x minus 6 again. Now the GCF is x minus 6. So we bring that in front, x minus 6. And then what we have left in the second set of parentheses is x squared plus 2. Okay. And number 13, with the first two terms, I would factor out a 4. And that would leave x plus 2y. Now, in this case, we have a minus or a negative sign right here. So when we're figuring out what is the GCF from those last two terms that we want to factor out, we want to make sure that we are factoring out a negative. So it's going to be negative 3w. Okay, so if I divide this by negative 3w, it's just going to leave x. And if I divide this by negative 3w, that's a negative divided by a negative. So that's going to be a positive 2y. All right. So then, and you can kind of tell, like, these are supposed to be the same. These two things that are in the parentheses are supposed to be the same. If they're not, you've made a mistake somewhere. So now that's your GCF. And then you would have 4 minus 3w in the second set of parentheses. Okay, all right. Just let me know if you have any questions. All right, the next type of factoring that we're going to look at is probably the most common one that people think of when they think of factoring. All right, so I'll just jump right in on an example. You've got x squared plus 11x plus 30, and you want to try, you want to factor that. So factoring is kind of, one way to think that a lot of people like to think of it as just reverse foiling. So I always start by writing down my two sets of parentheses. And then in order to get x squared, I would need an x and another x, like so. And then next I would figure out my my signs, positive or negative. So if I'm looking for two numbers that multiply to a positive, they have to be the same sign. And if they're going to also add up to a positive, it has to be two positives. That's pretty easy to figure out, I think. Then we're just looking for what two numbers would multiply to 30 and add up to 11. Okay, so that's a relatively easy one. But just in case, if you ever are unsure what your numbers are supposed to be, I just write down a list of everything that can multiply to 30 and just do it kind of in a systematic way, starting with 1 times 30, 2 times 15, 3 times 10, 5 times 6. All right, so those are all the pairs of numbers that multiply to 30, and then just figure out which one of those also adds up to 11, which would be 5 and 6. All right, and so, and it doesn't matter whether you put the 5 or the 6 first, either way, it doesn't matter. If they had different signs, you would want to make sure that you have the right number with the right sign, but All right, so number 2, same thing, just do your 2 sets of parentheses and then do your 2 x's. And then again, they're going to be both positives. And 2 numbers that multiply to 21 and add up to 10 would be 3 and 7. So there you go. Number 3, same thing. Let's do the 2 sets of parentheses, then do the 2 x's, and then we're looking for 2 numbers that multiply to 8 and add up to negative. Like, okay, so they're multiplying to a positive, which means they have to have the same sign. If they're going to add up to a negative, that must be 2 negatives. All right, and then again, we're just figuring out what 2 numbers multiply to 8 and add up to 6. So that would be 4 and 2. All righty. And then number 4, same thing. Let's do our 2 sets of parentheses. And let's do our 2 x's. And we're looking for 2 numbers that multiply to a positive, which means they're the same sign. And if they add up to a negative, then they must be both negatives. And 2 numbers that multiply to 12 and add up to 13 would be 1 and 12, or 12 and 1, either way. A lot of people forget that about that one, where it's 1 times the number. I think people tend to forget about that. All right. Number 5, do my 2 sets of parentheses, do my 2 x's, and this time we're looking for 2 numbers that multiply to a negative. So that means it has to be opposite signs, 1 positive, 1 negative. Okay, and then we just want to, so since they have opposite signs, that's made a little bit different because we're looking for 2 numbers that multiply to 36 and have a difference of 5. So that's going to be, let's see, so let's do our list. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so we're looking for one of those pairs of numbers that has a difference of 5. So that's going to be 4 and 9. And if we want to make that a positive 5, then we need the bigger number to be positive and the smaller number to be negative. So it's going to be -4 and +9. And it wouldn't matter if you put positive here and -4 over there, that's fine, just as long as 4 is negative and the 9 is positive. Number 6, 2 sets of parentheses, 2 x's. I'm looking for 2 numbers that multiply to a negative, so that means it's going to be opposite signs. One's negative, one's positive. So 2 numbers that multiply to 16 and have a difference of 6 is going to be 8 and 2. Okay. All right. Let's go ahead and do number 9. All right, so still going to do 2 sets of parentheses, and this time instead of squared, we have a squared, so that's going to be an a there. And then in this case, we also have that b squared at the end, so that means I'm going to put a b right here and right here. Sorry, I got disconnected there for a second. Not sure why. Fix my camera. My document camera keeps getting disconnected. Let me see if I can fix that. Maybe
I thought
it's
it was
connected to the internet or something. Okay, hopefully it won't keep happening. Okay, all right. Okay, so we're on number 9. All right, so we're looking for two numbers that multiply to 42 and add up to 13. So that's going to be 6 and 7. All right, and that's it for that one. All right, let's go ahead and look at number 11. So in that case, we can actually factor out the GCF. So anytime you're doing any factoring, it's always best to check to see if you have a GCF first. And in that case, we do. So let's go ahead and factor out the 4. So when we factor out the 4, we'll have x squared plus 7x plus 10. All right, and then we're going to leave that 4 in the front. And then just go ahead and do our 2 sets of parentheses, 2 x's, 2 numbers that multiply to a positive and also add up to a positive would have to be both positives. And then 2 numbers that multiply to 10 and add up to 7 are going to be 2 and 5. All right, but we still always have that 4 in the front. Okay. And then number 12 is kind of the same way. You're going to factor out the GCF first, which is 2. So it's going to be 2 parentheses x squared minus 10x plus 16. And then just leave that 2 in the front. And then do our 2 sets of parentheses and our 2 x's. And this time we're looking for 2 numbers that multiply to a positive, which means the same sign. Adding up to a negative means that's going to be both negatives. And then 2 numbers that multiply to 16 and add up to 10 are going to be 8 and 2. All right, and number 13, again, we want to factor out the GCF. And since there's a negative in the front, I'm going to go ahead and make it a -7 that I want to factor out. So -7, so then that's going to be a squared. So if we're factoring out a -7, so -7a divided by -7 would make that positive a, because the negatives cancel out. And then positive 84 divided by -7 is -12. All right, and then keep that -7 in the front and do 2 sets of parentheses and then 2 A's. And we're looking for two numbers that multiply to a negative, so it's going to have to be opposite signs. One's negative, one's positive. And we're looking for two numbers that are going to multiply to 12. And there's an invisible 1 right here. So they're going to have a difference of 1. Okay, so that's going to be 3 and 4. And since we want a positive 1 here, the 4 needs to be positive, and then the 3 will be negative. So see, negative 3 plus 4 would equal the positive 1. All righty. Okay, so the next thing we're going to look at is, so we're going to be factoring trinomials, and this is where we're going to have a number or a coefficient in the front that can't be factored out, basically. All right, so one way to do this is to use the AC method. But you can also do a guess and check method if you wanted to. All right. And both methods are good. So I like to talk about both of them. Try to get my camera situated here. All right. Okay. So if you were going to do the AC method, that means first, so A is the leading coefficient. That's the number that's in the front. And then C is the constant term on the end. So AC means you're going to multiply the A times the C. So AC, so in that case, it would be 3 times 10, which would equal 30. Then you're going to look for what two numbers would multiply to 30 and add up to 11. Okay, so if you make the list of all the numbers that can multiply to 30, and you could use your calculator to help you with that, you know, to like say, you know, take 30 divided by 2, it's 15, 30 divided by 3, it's 10. If you did 30 divided by 4, you'd find that it's not a whole number, so you would skip that one. And then, you know, 30 divided by 5, it's 6. So you can, if you wanted or needed to, you could use the calculator to help you with that. All right, so the ones that also add up to 11 are 5 and 6. Okay, so the next thing we're going to do is we're going to rewrite the middle term. So instead of writing plus 11x, we're going to replace that with plus 5x plus 6x. All right, so the 3x squared stays the same. I'm just going to bring that down. And then instead of plus 11x, I'm going to write plus 5x plus 6x. Okay, and again, it doesn't matter which order you put those in. And then bring down the plus 10 at the end. And then from here, we would just factor it by grouping. Okay, so grouping the first two terms together, we could factor out an x. And then that would make that 3x plus 5. And then group the last two terms together, and we could factor out a 2, and then that would be 3x plus 5. And then we have a common factor, which is the 3x plus 5. We factor that out. And then we're left with x plus 2 here. All right, and that's the final answer for that one. And again, you could check it by foiling. All right. Okay, number 2. So again, we would do, if we did the AC method, 5 times -6 equals -30. So again, the list of things that multiply to 30. Same thing we just did earlier. All right, so we're looking for 2 numbers that multiply to equal -30, but add up to equal 13. So if they're going to multiply to equal -30, they have to be opposite signs, okay, and add up to 13. So you might think, oh, well, 3 and 10 add up to 13, but they don't if they have opposite signs. So really think of which ones have a difference of 13, and that's going to be 2 and 15. So in order for those to add up to a positive 13, the 15 would need to be positive and the 2 would be negative. So we're going to replace this with -2x plus 15x. So bring down the 5x squared. And then instead of writing plus 13x, we're going to write -2x plus 15x. And then bring down the -6. Okay, and then we will group these. And then, so we could factor out x, and then that would be 5x minus 2. And then on the last group, we could factor out 3, and that would be 5x minus 2. And then factor out 5x minus 2, and then you'd have x plus 3 right there. And there we go. All right. And I mentioned that you can also use guess and check. So like number 3 is actually a really easy one to just sort of guess and check on. So I would just write down 2 sets of parentheses. And then in order to get 3x squared, the only option, because the only 2 numbers that multiply to 3 is 1 and 3. So you would have to have 3x and x, like that. Okay, and then in order to have 2 numbers that multiply to a positive and add up to a positive, you're going to have 2 positives. And then there's only one option for what can multiply to 1. It's 1 and 1. Okay. And then you can, so we've already basically designed it so that we know this times this equals this. We know 3x times x equals 3x squared. We know 1 times 1 equals 1. And we just need to check. The checking part is really just checking the middle term. So if you were to FOIL this, 3x times 1 would be 3x, and 1x times 1 would be 1x. And if you add those together, 3x plus 1x, it does equal 4x. And so therefore, this is the answer. And you could have also solved that using the AC method if you wanted to, but it was pretty easy to do it that way as well. Okay. So yeah, so you can always do either the AC method or guess and check, either one. They're both good. Let's see, what do we want to do? Let's do, so number 4, you could definitely do the AC method, but I think I want to try doing guess and check on this one and see how it goes. So first of all, I know I would need 2 sets of parentheses, like so. And then the only 2 numbers that can multiply to 2 is 2 and 1. So you'd basically have to have 2x and x like that. Okay. Now there's some other sort of variable things happening here. Let's see if I can find a pencil. Would be helpful. Don't usually have pencils. Should have thought of getting a pencil. Do I have a pencil? My mom doesn't have pencils either. I'm using her desk. She's got all the pens. Let's see. Oh well, that's okay. Guess I'll get by. Okay, so let's see. Well, let's figure out what can multiply to 6. So, because I know these are going to have opposite signs, and I don't know which one's going to be the positive or the negative yet. That's why I was looking for a pencil. You really should always do math in pencil, guys. I'm not being a very good example because I always do it in pen, but you should really do it in pencil. Okay, so what can multiply to 6? Well, there's not too many options. There's 1 times 6, or there's 2 times 3. So those are the only 2 options. Okay, now let me show you a little trick here. Okay, so whichever number that goes here. So basically I have 4 options for what number can go right here. Okay, but I'm going to narrow that down because I cannot put a number here that has a factor of 2 or is a multiple of 2. So this 2 can't go there and the 6 can't go there. Okay, so only it can either put the 1 there or the 3 there. All right, so let's see. So let's just try putting the 1 there. So if the 1 is there, that means the 6 has to go here. Okay, now let's see. Is this going to work? Because if we were to FOIL this, this would make 12 and this would make 1. Okay, there's no way 12 and 1 can make this 1 in the middle here. All right, so that is going to be a no. All right, that's why I wished I had a pencil. Oh well. There we go. So then let's try. All right, so now my only other option for what to put right here, like I said, it can't be the 2 or the 6 because those are multiples of 2. And we tried the 1 and that didn't work. So it has to be the 3. So that has to be the 3. And if that's the 3, then this has to be the 2. All right, so I know that's right. And then now I just have to figure out where to put my positive and negative. So let's see. This is going to be 4, and this is going to be 3. So in order to make up a negative 1, I want the 4 to be negative. So that means I'm going to put the negative here and the positive here. And you could also just guess and check on that. You know, just put that there and just check. And if it doesn't work, then just switch it. So like that's negative 4 plus 3 gives me that negative 1. And so that's my final answer. All right, so that kind of might have seemed a little bit awkward, but I think it's good. Like once you get the hang of it, it can be a lot faster and everything. It could be a good option. Okay, let's see here. Number 5. Okay. Sometimes I actually like to do like a combination of the AC method and the guess and check method kind of together. So let me see how that might work. Let me write down a couple sets of parentheses. Now, one good thing about this problem is I know that both my signs are going to be positive because they're going to multiply to a positive, they're going to add up to a positive. So that's one thing I definitely know for sure. All right, now let's see here. So things that multiply to 4 are 1 and 4 and 2 and 2. So that's my options for that. And things that multiply to 6 could be 1 and 6 or 2 and 3. And so there's my options for that. Okay, so now I kind of do the AC method in my head sometimes, like, okay, well, if I multiply that times that, that's going to be 24. So what two numbers multiply to 24 and add up to 11? So I know that that's going to be 3 and 8. So if I'm looking for 3 and 8, the only way to get 3 is to have 1 times 3. So let's see. I'm going to put the 3 here. If I have the 3 here, that means I definitely have to have the 2 there. And I want to have 1 times 3. So if I want this to be a 1, then that has to be a 4. Okay. So I don't know if that made sense. But it's just something that the more you do it, you kind of get the hang of it. Now, let me go ahead and check to make sure that I got this right. So I've got 4x squared here, I got 6 there, so that's good. The main thing I want to check is the middle number. So to check that, okay, 4x times 2 would be 8x, and then 3 times x would be 3x, and 8x plus 3x does equal 11x. So that is the right answer. Okay. So yeah. And so again, you can't have, you know that you can't have a number here, like these two numbers can't have any common factors, basically. So because if they did, then you would have had a common factor to factor out up here, but you didn't. So, so yeah, or you can always use the AC method. The nice thing about the AC method, it's very straightforward, step by step. You just do the steps and then that's it, you're done. Okay. Let's see. Do you have any questions, comments, anything?
I think I get what you're saying with the checking the problem, and then also the other one where you crossed the 1, 6, 2, and 3. So
Okay. Do you want me to do, would you like me to do another example of like either of doing the guess and check method or the AC method? Or
I like another one of the AC method.
of the AC method? Okay, good deal. I'll do that. All right, let's see which I'm gonna do. Let's do this number 7 right here. That'll be a good one. All right, so let's do the AC method again. So in that case, A is 6, C is -10. So I'm gonna multiply those together. So 6 times -10 equals -60. All right, so let's figure out what can multiply to 60. So 1 and 60, 2 and 30, 3 and 20, 4 and 15. And like I said, if you're not sure about all this list, you can always use your calculator to just like divide by 2, see what you get, divide by 3, see what you get, divide by 4, see what you get. You know, if it doesn't come out to a whole number, then you just skip that one. 5 and 12, there's a lot here, 6 and 10. I think that's the last one though. Yeah, because like 7, 8, 9 wouldn't go into it. All right, so then we're gonna look for out of that list, oops, sorry, list is off the screen. Out of that list, which ones can we make 11? So we're looking for which two numbers can multiply to a -60, but also add up to a +11. So we're basically looking for two of these numbers that have a difference of 11. So just look down the list and we want to find the pair that have a difference of 11. And that is going to be 4 and 15. So in order to make that into a +11, we want the bigger number to be positive and the smaller one to be negative. So it's going to be -4 with +15. Okay, so we're going to rewrite the problem, bring down the 6x squared, and then in place of the +11x, we're going to have -4x plus 15x. All right, so you notice that negative 4x plus 15x is equal to positive 11x, right? So we're kind of just breaking that up and rewriting it. And then we can bring down minus 10. And now we can factor it by grouping. So group the first two terms together. And so the GCF from those two terms is going to be 2x. We factor that out. It'll leave 3x minus 2. And then from the last two terms, the GCF would be 5. And we factor that out, and it leaves 3x minus 2 also. And then 3x minus 2 is the GCF, so we factor that out, and then that leaves us with 2x plus 5. And that's our answer for that. So the AC method is an option that you could use for any of these problems, and it is nice and straightforward, and it's just a step-by-step method. Or you could, so you could use either method. You could use the AC method, or you could do the guess and check method. Either one will be fine. And like I said, the guess and check method, it might seem kind of like cumbersome at first, but once you practice with it, I think you can get quick at it. Okay. Let's go ahead then. What else do we want to do here? Let's see. Let's just look at this problem right here, and that looks like an easy one. Two sets of parentheses, two x's, two numbers that multiply to a positive and add up to a positive would have to be two positives. And then we just have to figure out what two numbers could multiply to 40 and add up to 12. Well, let's think of all the things that can multiply to 40. 1 times 40, 2 times 20, 4 times 10, 5 times 8. I think that's all the numbers that could multiply to 40. And if we look at those and we look for, okay, which of those pair can multiply to 12? Well, actually, none of them can. So a little bit tricky there. So that actually means, so this isn't going to work here. And this trinomial here is what we call prime. And this means it can't be factored at all. So there you go. Sometimes that happens. All right. Let's look at differences of squares. Differences of squares is a pretty easy type of factoring to do. So whenever you have two terms and both of them are perfect squares and then they're subtracted, there's a minus in the middle, that is what we call a difference of squares. All right, so x squared minus 100, when you factor that, it's just going to be x plus 10 times x minus 10, because x times x gives you the x squared, and 10 times 10 gives you the 100. That's because 10 square, in other words, the square root of 100 is 10. And it doesn't matter plus or minus, either one, like the order doesn't matter for that. Easy peasy. Number 2, that would be 10x plus 7 times 10x minus 7. Number 3, that would be 5x plus 1 times 5x minus 1. Number 4, that's 7x plus 2 times 7x minus 2. Number 5, that would be x plus 6, x minus 6. number 6, that would be 1 plus 8x times 1 minus 8x. All right, make sure that that's not the order that we're used to seeing it in as often, but that's okay. Just leave it like that. You have to just leave it like that. Okay. Number 7, that would be 5x plus 9y times 5x minus 9y. Number 8, that would be 4a plus 5 times 4a minus 5. Number 9, okay, that's not a square, but what we have here is we have a GCF. So the GCF in this case would be 2. So let's factor that out first. So we factor out a 2, and then that would be 9n squared minus 16m squared. Now those are both perfect squares. So just leave that 2 in the front, and then you'll have 3n plus 4m times 3n minus 4m. And then on number 10, again, you've got to factor out the GCF first. Okay, so this number ends in a 5, so I know it's divisible by 5, and then obviously that is. I'll just go, I think I know what the answer is, but I'll just go ahead and use my calculator. 3125 divided by 5 is 625. Okay, so factor out the 5 first. And that's 625 x to the 4th power minus, oops, the 5 is gone now, and that's just y to the 4th power. All right, so now anytime you have an like an even exponent here, that's a perfect square, because when you're just gonna like basically divide it by 2. All right, so that's a square. That's actually 25 squared. And if you didn't know, you can just do square root of 625 is 25. All right, so keep that 5 in the front. Then we have our difference of squares. So this is going to be 25x squared plus y squared times 25x squared minus y squared. Now, this part right here is another difference of squares. All right, if it has a plus, that's not a difference, that's a sum of squares, and that can't be factored, that's prime. So just bring down the 5, and then bring down that first set of parentheses with 25x squared plus y squared. Then we're going to have 2 more sets of parentheses, and this is going to be 5x plus y times 5x minus y. All right, and that's what we call fully factored, all the way factored. And then that 5 isn't a square, so that's prime. Can't be factored. And that's a sum of squares, which is also prime. Okay. And I'm running up on the end of my time. Let's see. Okay, I didn't want to cover that part anyway. The last thing I was going to cover is solving equations by factoring. So once you know how to factor, solving the equations by factoring is really easy. So you might see where they call this the zero factor property, which just means that if 2 things multiply together equal 0, then at least one of those 2 things has to equal 0. So basically, if you have something that's factored equal to 0, like this, then you could basically just say x plus 3 equals 0, x minus 5 equals 0, and then those are real simple to solve. So you get x equals 3 is an option, is like one of the solutions. and x equals 5 is the other solution. And eventually you'll realize that if you see something like this, oops, that's -3. You'll realize that, okay, if you see this, that you know it's just going to be whatever the opposite of that number is. So x is -3, x is +5. So you just, basically what you want to do to solve this, make sure you have everything on the left side with 0 on the other side. Then you factor it. Let's see, that'd be x minus 5 times x plus 4 equals 0, which basically tells me x is going to be equal to 5 or -4. I just skipped that step in that case. Let's see. So like on number 3, you would either use the AC method or the guess and check method. I'll skip that for the moment. Number 4, in that case, you would factor out a greatest common factor of x. That would be x times 8x minus 1 equals 0. And then your two factors that you set equal to 0, one of them is this. So one of them is going to be x equals 0. And the other one's going to be 8x minus 1 equals 0. And then you want to solve that for x. So you add 1 to both sides. You get 8x equals 1, and then divide both sides by 8. So that gives you x is equal to 1/8. So your two answers you have there is x equals 0 and x equals 1/8. And like on number 5, your first step for that would be make sure you get everything over to the left side. So you would be adding 10x to both sides, and you would be subtracting 4 from both sides. All right. None of those are like terms over here. So all you really do is you just write down 24x squared plus 10x minus 4 equals 0. And then from there you could factor it and all that. Like on this one right here, you would have to actually FOIL this, distribute that, get everything on one side. I guess maybe I'll run through that one real quick. So if you FOIL this, you're going to have x squared plus 4x minus 5x minus 20 equals 2x minus 10. And then that's going to be x squared minus x minus 2 equals 2x minus 10. And you want to get everything on one side. So you subtract 2x from both sides and you add 10 to both sides. And then that gives you x squared minus 3x plus 8 equals 0. Is that right? That don't seem right. Because I don't think that oh wait, I see what I did wrong. I see where I messed up. Right here, 5 times 4 is 20 and I wrote 2. 20, okay. So then -20 plus 10 would end up being -10. Instead of plus 8, this would be minus 10. Okay, then you could factor it. It'd be x minus 5 times x plus 2 equals 0. And then your final answer would just be x equals 5 and -2. All right. All right, so that'll be the end of that for today. Any questions about anything?
Good with everything.
All right.
Sounds good. Have a good weekend. Bye-bye.
Bye.